Section 4.6 is the last section in Unit 4, which means your test will be shortly following this coming up next week. The last section has about 4 different ideas on it that you're going to have to know, some of which are common sense and some of which may or may not make sense to you. Let's hopefully I can explain it to you and we can go from there. The first main idea is this. In triangles, the largest angle lies opposite to the largest side, meaning the largest angle is always across from the largest side. If you think about making an angle, let me just kind of draw a couple pictures for you and see if this kind of makes sense. If I have an angle and it's kind of medium size, and I have an angle and it's kind of smaller, and then I have an angle that's really, really big. Let's go with that, okay? When you have a small angle, the side across from it is small. If I have a medium angle, the side across from it is medium. If I have a large angle, then the side across from it is usually the largest side. That's how it works. It always is, as a matter of fact. It's not usually, it always is. The smallest angle, what's across from it, will be the smallest side of the triangle. That should be somewhat common sense. As you open up something, I'm trying to make it bigger, then the side across from it is going to have to get bigger. That's how it works. I'm hoping you can see, and I'm going to ask a variety of questions that we'll see if you understand that. So let's look at number 4, and we'll go from there. Number 4 says, this is in your book, so you feel free to do this in number 4 in the book. Pretty close. I'm almost where I want it. Okay, let's try that. Here's number 4. In triangle ABC, where AB is 8, BC is 5, and CA is 7, list the angles in order from smallest to largest. Well, if I want the smallest angle, I need the smallest side. Here's the smallest side. If you know that side BC is 5 units long, then which angle must be the smallest? Which one is across from BC? Angle A. For those of you who do not see this, what you could do is you could draw the triangle ABC, and you could think that BC is the length of 5 units. So what's across from BC will be the only angle that's not being used at that point in time. It's angle A. That's your smallest. And so now let's look for the medium size. Let's see, the middle one. The middle one is CA is 7. What angle is across from CA? Go ahead and say the letter out loud. B. Angle B, don't forget. And lastly, our largest angle is going to be angle what? C. Angle C. They are across from the largest or longest. I think the thing that I need to warn you about is always pay attention to what you're supposed to do. You're supposed to go from smallest to largest. It could very well be the largest to the smallest on any quiz or test. You just have to pay attention to that. The next thing that we're going to talk about, idea number 2, is the triangle inequality theorem. The triangle inequality theorem is how you can determine if you can make a triangle or not. The triangle inequality theorem says that the sum of the 2 smaller sides has to be greater than the third side in order for you to make a triangle. Here's what I mean. If I had the side length of a 2 and a side length of a 3 and a side length of a 7, you cannot make a triangle out of that. And I'll tell you why. Because the 2, if I put it right here on the edge of 7 and the 3 right here on the edge of 7, if you think about bringing those closer and closer, trying to get them to touch, this is not long enough, nor is the 3 long enough for them to meet. The only way to get to a triangle out of this is to slide the 3 over, and then what you would have is you would have something that is no longer 7 units. In order for you to make triangles end to end, the two smaller pieces have to add up to be greater than that third piece. As somebody asked in my other class, they said, Mr. Parama, what about if it was 5? What about it wasn't 3? What happens if it was 5 and 2 and 7? And I said, well, then what you would eventually have is a 2, and you would have a 5, and you would have a 7. And they're basically only long enough to be the same distance. Is there enough to make a peak? And the person said, no, you can't make a peak there. It has to be greater than that third side. It cannot be equal to it. But if you had a 5.1, then what's going to happen is then you start making triangles from that point on because it's greater than. I hope that makes sense to you. So that's the triangle inequality theorem. Here is an example. And here's number 7 in your book. Can a triangle have sides with the given lengths? Explain. 2 inches, 3 inches, 6 inches. Look at it. And now say, is your answer yes or no? Say it out loud.
Yes.
How many people say yes? Raise your hand. I would say no. Raise your hand. The majority is no, and the no's are correct. The reason it is no, my explanation is this. Here's the two smaller. If I were to add those up, it is not greater than 6. 5 is not greater than 6. So I put a little line through the greater than symbol. That's my explanation. I don't need to write out a bunch of words. I can say that I added the two smaller pieces, and then it's not greater than the third piece. By the way, I'm going to give you a hint here. The way they try to make this more confusing is sometimes they're going to put the order differently than what it is. And they might throw the order like this, and so some of you who aren't paying attention will just do 6 plus 3 is greater than the 2. But remember what the triangle inequality theorem says. It says the two smaller sides, no matter what order it's given to you in. So if they do that, don't forget these are the two smaller, and it doesn't necessarily isn't given in order per se. The third idea that they are going to have you do is talking about the range of possible lengths for the third side of a triangle. They're going to give you 2, and you have to figure out what that third possibility can be. And we'll just simply figure out what the possible values can be by putting them between the difference and the sum with a less than and a less than symbol. Meaning these values are going to be bigger than the difference and smaller than the sum. I know that looks a little bit different, but the less than means that these values are going to be between the difference and the sum of the numbers. So let's look at number 9. And number 9 says this: the lengths of two sides of a triangle are given. Find the range of possible lengths for the third side. So all you really have to do with 18 and 23 is you need to figure out what their difference is. I'm going to subtract 23 minus 18. If you did 18 minus 23, that would be fine. It's the absolute value. It's a positive distance. That distance is 5 units. It's less than x. It's less than their sum. 18 plus 23 is what number? Say it out loud.
41.
Thank you. What this is saying, when you write your answer like this, 5 is less than x is less than 41, means that the third side has to be between 5 and 41. That nothing else would work. If you tried to use 5 plus 18 would be 23, and it would make a triangle. But so if it was bigger than 5, like 6, then these two would have to be greater than that, and then it would work. But we can't go more than 41, because if I had 41, then these two added together would not be greater than that. So the values have to be between 5 and 41 to make that triangle. That's what this says. Just the difference in the sum with less than in between. Lastly, here's the last idea. Sometimes you're going to be given two triangles, and sometimes they're going to ask you what's the longest or the shortest piece in both triangles. When you are doing that, like number 20, the key to doing it is figuring out what the angles are in both triangles. And then what we're going to do is find the largest or the smallest side across from it and check the smallest / largest angle in both triangles and compare, and the shared side is what's going to let you know what is the correct answer. When I look at number 20, there's a few things that jump out at me. The first thing is that they give me a 30-degree angle and it's isosceles, so I know that this has to be the same as this by the isosceles triangle theorem, and that there's 150 degrees left in this triangle, and 150 divided by 2 is 75 and 75. So I'm going to start off by finding all the necessary or the included angles there. I'm also going to find the angles over here. This is 50, 40 makes 90, and then another 90 makes 180. And the question says, determine which segment is the shortest in each diagram. So what I'm going to do is I'm going to think of this green triangle and this blue triangle. I'm going to try to find the shortest side in the green triangle, and I'm going to try to find the shortest side in the blue triangle, and then I'm going to compare. Smallest angle? Oh, QR is the smallest in the green triangle. Has to be. I look over here in the blue triangle, 40 degrees. Oh, RS is the smallest angle, so RS is the smallest side. Well, let's compare. Is QR smaller than RS? Well, since QR is in both, this is in the green triangle and the blue triangle, and so let me say this is the smallest there, this is the smallest there. 50 degrees is the middle side of the blue triangle, and that's across from the smallest in the green. Since this is the middle one, and there's something smaller than that angle, then this must mean that RS is the smallest of them all. That's my logic. My logic is to compare, finding the smallest angle and then the smallest side, and then looking in the other triangle, is that the smallest in this triangle as well? If not, then you know that this has to be smaller than that. Here's what my warning to you is. Do not assume that the smallest angle is going to be across from the smallest side when there are two triangles or more. You're going to have to do some logical deductions to figure out what the answer is. With that being said, I'm going to stop your notes right there.